So today we're really just discussing arc length. And an example of arc length would be essentially how long part of a circle is. So if I were to take this arc and lay it out flat, how long is that? Okay? So arc length is really just a fraction of the circumference. That makes sense logically?
Yeah.
Arc length is a portion or part of the entire circumference. Okay? And sector area is really just a fraction of the whole area, right? Okay. So sector area is a fraction of the total area. Okay? So that's what we're working with today. We're working with arc length and we're working with sector area. One is a fraction of the circumference, the other one is a fraction of the total area. How are we doing so far? Yes, no, if you like we kind of understand what we're doing? Okay? Coming back to our track example, when we found this arc length right here, what fraction of the whole circle was that? Just this arc length right here. Half, right? Isn't this half of the circumference? Okay? What would the measure of this arc be? You've done this already. What would the measure of this arc be? Not the length of the arc, the measure of the arc. 180? Is that what I heard? Because why? What is that? Half a circle, a semicircle, right? The measure of this arc is 180 degrees. The length of that arc is 94.25 meters. Okay? Very important. Do you understand the difference if I ask you for the measure of the arc versus the length of the arc?
Yes.
The measure of the arc will be labeled with degrees. It'll say m in front of it, but when you write your answer, you'll label it, 180 degrees. And the length of an arc will be in units, whatever units it is, meters, inches, miles, whatever. Okay? So there's a difference between measure of an arc and length of an arc. Okay? So we really just got done doing arc length right here, and then when we found the area of this, we were really doing sector area. Okay? So, I'll give you an example of a problem here. Let's find an arc length. Of AB. Alright, so let's say it has a central angle of 60 degrees, the radius is 10, and I want to know how long that arc right there is. What do you think we need to do? Find the whole circumference. I think that's a great idea. Let's find the total circumference first. Okay? Total circumference. How do we find total circumference? 2 pi r. So 2 times pi times 10, right? So in other words, that'd be 20 pi. I'm not going to get the decimal right now. I'm just going to leave it in terms of pi. It's a lot easier for me to just do the math in my head. Okay? So the total circumference to go from here all the way around back to A would be 20 pi units. All right? Let's put some feet. Put a here and we'll go feet. Okay? So it takes 20 pi feet to go all the way around the circle, but I just want to know how far it is from A to B. What do you guys think?
Isn't the arc the same as the angle?
Mm-hmm.
So
If this angle here is 60, then isn't the measure of that arc also 60? Keep going.
25 feet from 60, or 60 from 25 feet. To find that.
No, because the 60 degrees is not a length. This is a length. 60 degrees is not a length. That's just a measure in degrees. Quinn.
You divide 20 pi you divide by 6.
Why?
Because 60 is 1/6 of 360.
Perfect. I'm going to change how you do it, but what you said is right. Okay? Here's my question to you. What fraction of the circle is this right here? What fraction of the circumference? 1/6. Because how far is it all the way around the circle? In a measure. 360 degrees. How many degrees are we concerned with right now? 60. What fraction is 60 of 360? 1/6. If you don't know that, just leave it as 60 over 360. Okay? If I ask you what fraction of the circle are we concerned with, I would say we have 60 3/60ths of the entire circle. Or 1/6, as you guys have said. But now if this was 61 degrees, then what fraction of the circle would I have? 61 3/60ths, right? So if I just take this fraction and I multiply it by my 20 pi, I'll have my answer. Because this is the total circumference, but I'm only concerned with 1/6 of it. You said divide by 6. Isn't that the same thing as multiplying by 1/6, which we're going to do now? So if you take 60 over 360 times 20 pi, you will get your answer. I'm going to leave it in terms of a fraction right now because I think it's easier. So 60 over 360 reduces to 1/6. And then when I take 1/6 times 20 pi, I'll get 20 pi over 6, which would reduce to 10 pi over 3, and that will be in feet. I'm going to leave it in terms of pi. You probably are going to get out a calculator and actually type that in. Okay? Any questions on that? If you are dead set on formulas for arc length, if you like to memorize formulas, take the measure of the arc over 360 times 2 pi r. Find the measure of the arc over 360. That gives you the fraction, right? In our example, we had 60 3/60ths. If that central angle was 73 degrees, I'd do 73 3/60ths. And take that times 2 pi r, and that will give you how long that arc is. Everybody okay with that? So before I do an area one, take a look at this. Look at what we did. I took the fraction that I have times the total circumference, right? Want to take a wild guess on what the formula is going to be for the area part? Exactly the same, except what? This is going to be pi r squared. Because we're working with area and not circumference. So again, if you like formulas, in order to do a sector area, you're just going to do the measure of the arc over 360. That's the fraction of the circle I'll be finding the area of. And I'm going to take that times pi r squared, my total area. So it's really pretty simple. Think about what fraction of the circle we're trying to find. Take that fraction times the total area, or if it's arc length, the total circumference. Okay? I'll do one example of this. Everybody got this formula written down that wants it? Okay? So let's find the area of the sector. Let's find the area of that sector. What am I going to do? 110 over 360, because that's the fraction of the circle that I am interested in, right? So 110 over 360, because what's the measure of that arc? 110. Why is this 110? Because my central angle is 110. So 110 over 360 times the what? The pi r squared, which represents the whole area, right? I'm going to take the fraction of the circle that I'm interested in times the total area. Which, how do I find the total area? What's the formula? Pi r squared, right? So 110 over 360 times pi r squared. Okay? So you can get out a calculator if you'd like. I'm just going to reduce.
Please report to the lobby. Ryan Bowles, report to the lobby, please.
I'm going to reduce. That becomes 11 over 36 because both of those are divisible by 10. I'm going to take that times 64 pi. I didn't put the label. Let's go centimeters this time. I'm going to reduce. Both of those are divisible by 4. So that would become 9. That would become 16. I don't think I can reduce any more. 160, 176. 176 pi over 9 centimeters squared. Okay? 11 times 16 is 176, so 176 pi over 9 times 1, which is 9. Or, what is it as a decimal? Somebody who's done it on the calculator?
61.44.
Any seconds on that? No? Different? 61.44? Okay. So approximately 61.44 centimeters squared. So if you round your answer using decimals, this is what we're expecting to write your answer there. That seems to make sense because that's almost 20, and 20 pi would be a little more than 60, so I would say you guys are right on the calculator there. Okay? So, arc length and area of sector, pretty easy. Take the fraction of the circle times the circumference, or take the fraction of the circle times the area. Pretty self-explanatory there? Okay.